Hi everybody online as well. Pleasure to be here in person. Really, thanks for a lot to the organizers. Let's see. So this was obviously a project from the cycle that just ended in March. Marine oil spill studies. We chose the acronym to be quite evocative of the BC North Coast, MOSS. And this is the project that involved mostly GSC proponents, quite a few people from GSC, but also from Canada Energy, from DFO, NRC, and a couple of academic partners as well. So for context, Canada's coastal waterways are generally facing multiple pressures from different angles. The map shows you an overview of the amount of tons handled by marine ship traffic. And along those waterways, there are environmental forcings that are exerted from different mechanisms, but the end result is pretty much similar. So warming is ubiquitous, pretty much ubiquitous. And there's another trend, a global trend, again with different mechanisms, but it is affecting both coasts, and that's the declining oxygen concentration at depth. And part of the GSC's mandate is to really ensure environmental stewardship when it comes to the exploitation of natural resources. So that includes transport, hence the marine oil spill component to this project. So the study site is the Kitimat Fjord system on the BC North Coast. This is an aerial shot of the town that's lodged in the beautiful and pristine Great Bear Rainforest. And we chose this site for a number of reasons. One was opportunity. So Quinn's group and colleagues at the PGC had a lot of sediment samples available, bringing the cost of fieldwork to zero for EGP. So that was a little bit. And DFO also provided a lot of material. Kitimat hosts a wide variety of industries. There's an aluminum smelter, there was the Eurocan pulp mill, and more relevant to us, directly relevant to us, there are quite a few large liquefied natural gas terminals to export natural gas to international markets. The fjord system was also the site of the largest oil spill in BC's coast history. It's nothing as dramatic as the Exxon Valdez or the Deepwater Horizon. It was much smaller. It was still the largest spill that the West Coast experienced. And that was the sinking of the ferry, the Queen of the North, when it failed to make a turn and avoid Gale Island. I see a smile there. Somebody knows, remembers the story behind it. So the objectives as a whole, there are two main objectives. One, and the main angle is using sedimentary archives and different tools to read those sedimentary archives. The first role is to determine a baseline of natural variability and historical human impacts in the system. And the second component is really more the oil spill component to the project. It is to estimate the capacity of microbial communities who really are the first responders in case of an oil spill. So to determine their capacity to degrade spilled oil in the case of an oil spill and under reduced oxygen concentrations. So let me go back. We have quite an extensive set of surface sediment samples. We have a sediment trap time series as well as sediment cores to go back into time. And all that material being provided by PGC colleagues. A few teasers. This is very much work in progress, but hopefully you'll get teased a bit. So Jason here analyzed the pHs, and these are a few examples. On the left-hand side, you have routine, which is an indicator of conifer combustion, and you see pretty much background levels all across the system, except for one point source, and that was the Eurocan, the pulp mill that operated for about 40 years. It closed in 2010, but you can really trace back this point source of specific pH. And then on the right-hand side, you have chromonine, which is a marker of fossil fuel combustion. And you can see a slightly more diffuse signature around the head of the system. It is a big system. If you check the scale, it is a pretty massive body of water. And kind of surprisingly, this is the site of the wreck of the Queen of the North, and there's really no clear pH signature. Nothing really stands out. Another tool we're using to read the sedimentary archives are dinoflagellate cysts and pollen spores. So they're polynomorphs, and that's my specialty really. The middle panel, you can see the ratio of dinoflagellate cysts to pollen and spores. So dinoflagellate cysts are produced in the marine environment. Pollen and spores are produced by land plants. And so the ratio between the two tells you the terrestrial versus marine source of the organic matter, basically. Then you can see more marine signature in more distal places and more terrestrial signatures proximally. And then you have some species that are occurring that really prefer more pressure, brackish conditions, and some who do better in more distal settings. Just to give you an example of how we can read the environmental signal encoded in the sediments. To go quickly to address the second objective, so really the oil spill components, we simulated oil spills in the lab in a way that's a little bit similar to Jason's, except using much, much smaller bottles. These bottles would fit in my hand, nowhere near those large columns. So we tested the natural oil degradation at the sediment-water interface. So the recipe in each of these bottles, you put some sediment, some local sediment from the kinematic rock system, some seawater, and you inject a little bit of oil to simulate the oil spill. And we did that in triplicates and with under a range of fully oxygenated concentrations, fully anoxic, and something in between. And we forced the oxygen concentrations over the course of the experiment, which lasted about 4 months, and by controlling the gas composition in the headspace of each bottle. An overview of the activity over the 4 months of the experiment in terms of oxygen drawdown and carbon dioxide production. You can see not much happening in the anoxic bottles, not much microbial activity, and pretty similar behavior between oxic and hypoxic conditions. We kept track of microbial communities. The graph on the left-hand side gives you an idea of the total microbial biomass, and you can see lower biomasses under anoxic conditions. And then with sickness RNA sequencing, we can keep track of which components of the microbial community took over. And we noticed an increase, a notable increase in some hydrocarbon degraders, particularly in the phylum Procteobacter, and that was true for the oxic and hypoxic settings. You can see higher abundances in the last time points, and again, not much happening under anoxic conditions. We kept track of which components of the oil were being degraded. This is the first graph. So here it shows you the profile of the enantians. Thank you. So the chains, the easiest components to chew on for microbes. So these are profiles, and the different time points are going down. So pretty similar behavior between oxic and hypoxic conditions in terms of degradations of chains of hydrocarbons, and not much happening again under anoxic conditions. This is a summary of all the major classes of compounds that can be measured from the time-of-flight mass spectrometer. So anything that can go through gas chromatography that can be detected. And the total is summarized in the first column of each graph here. We have alkanes and several classes of pHs, but you can see similar degradation between oxic and hypoxic conditions, slightly more complete under oxic conditions, and again, not much happening under anoxic conditions. So we have a lot more data. Jason ran some PLFE analyses as well that show that the microbes did indeed use the oil as a source of carbon, but that's all I'm going to present right here. So a couple of take-home messages. there are clear environmental signals encoded by both biological proxies and chemical proxies. The pillar environmental constructions are to follow, so please stay tuned. There will be more. And the final quantifications of all the GC time of flight MS are still underway. We're really close, but right now I think you can get the picture that if there's an oil spill happening in an area that has less oxygen available to fuel microbial degradation, it will take longer for the system to naturally clean up itself. Thank you.